Okay, today we're going to be going through lesson 7.4, focusing on the peripheral nervous system. Now, we refer to the peripheral nervous system as the PNS, as we saw with the central nervous system, the CNS. So we have nerves and ganglia that are outside of the central nervous system, and this is where we have our true nerves definitively, which are going to be a bundle of neuron fibers. Neuron fibers are bundled by connective tissue very similarly to how we saw with the muscular system. Okay, so let's get right to this picture, figure 7-23. So we can see that we surrounding the entire nerve, we have the epineurium, we have the perineurium surrounding our fascicles, and then endoneurium surrounding individual nerve cells. Very similarly to what we saw with the epimysium, perimysium, and endomysium in the muscular system. Now, we do have mixed nerves. Within these, we have both sensory and motor neurons, motor fibers, We have our afferent nerves and our efferent nerves. Again, we should already know what those are. But something new to talk about are the cranial nerves. Now, these are 12 pairs of nerves that mostly serve the head and the neck. There's only one pair of vagus nerves that extend to the thoracic and abdominal cavities. We'll see those in just a second. Most are mixed, but the three are sensory only. So we have a list right here that goes through these. I'm just going to jump to our table right here and talk about this table briefly. So table 7.1 outlines your 12 your 12 cranial nerves, and it gives the name and the number. They are assigned a Roman numeral, their origin and their pathway, what they do, and then how they are tested. Okay, so a good example of this is with the oculomotor nerve. When you go to the doctor, they shine that light in your eye. They do that to make sure that there is a proper response there. Okay, so continues on, goes through all 12 pairs. I want to jump down to pair 10, the vagus nerves. And again, these are all paired nerves. So we see that the fibers emerge from the medulla, they descend, and what they do is they carry sensory impulses from the motor impulses and motor impulses to the pharynx, larynx, and the abdominal and thoracic viscera. Most motor fibers are parasympathetic fibers that promote digestive activity and help regulate heart activity. So they travel to the thoracic cavity and work primarily with homeostatic mechanisms. Okay, so figure 7.24 gives a pictorial representation of these coming off as well, and you can see where they go. Make sure to reference this diagram in your assignment. So let's start with the spinal nerves now. So there's a pair of spinal nerves at the level of each vertebra for a total of 31 pairs. They're formed by the combination of the ventral and dorsal roots of the spinal cord. And so they, each branch comes off, they come together and then form the nerves. And they're named for the region of which they arise. So the cervical nerves, hence the name, they come from the cervical region of the spinal column. We see the same with the thoracic, lumbar, and sacral nerves as well. Okay, so we see right here we have some plexuses. Okay, we see this connection right here. We see the same with the brachial plexus dealing with the arm, and also the lumbar plexus and the sacral plexus functioning with coordination of movement of the appendages. Now, spinal nerves will very quickly divide soon after leaving the spinal cord. So your dorsal rami, they're going to serve the skin and muscles of the posterior trunk. The ventral rami will form these plexuses in the rear. So figure 7.25 shows the distribution. This is the rib cage right here that you would see comes out of the spine and comes around and branches together. You can see this connection right here. Okay, so you have your dorsal ramus. Remember, this is the back side of the body. This is the ventral or the anterior or the front right here. Okay, so table 7.2, again, a wonderful table, gives just, a very, very quick breakdown of all of these, very straightforward. Make sure to reference this in your assignment as well. Goes through the major plexuses, so the cervical, brachial, lumbar, and sacral that we talked about. So you can see right here with your roots that you have. Okay, so coming off the cervical right here, and then branching down, you can see that we right here, for example. Okay, so we have I'll talk about the axillary nerve in just a second, but the humeral and I'm sorry, not the radio. Goodness, the musculocutaneous nerve. Okay, coming right here, we see this branching where it's all connected together with the ulnar nerve, radial nerve, all of these. And again, that's it's done to really help facilitate ease of movement. Now, with the axillary nerve coming right here to the deltoid muscle, it picks up sensation, that burning feeling when you get a shot. Okay, so we see very similar concepts in the lumbar plexus, as we see right here, the femoral nerve branching into its different divisions, and then we have the coming down towards the calf muscle. But you'll notice that we don't have any nerves going to the ends of the end of the feet. That's because they come out of the sacral plexus, and we have the sciatic nerve. So, if you ever heard your any family member say they're having sciatica, what that is, that's inflammation that of the nerve itself, or either pinching off of the nerve, causing numbness, sharp pain, whatever the case is. Okay. All right, so now we need to talk about the autonomic nervous system. This is some pretty pretty deep vocabulary and concept stuff. So make sure you're following along as best you can. So we have motor subdivisions within the peripheral nervous system, where we have only motor nerves that are shown. Now, it's also known as the involuntary nervous system. It's going to regulate the activities of cardiac and smooth muscle in our glands. And we have two subdivisions, the sympathetic and parasympathetic division. Now, the differences between the somatic and autonomic nervous systems: with the somatic, you have one motor neuron. With the autonomic, you have a preganglionic and a postganglionic nerve. Okay, so we have a minimum of 3 nerves here. Okay, so you have your effector organ somatic, it's going to be your skeletal muscles; autonomic, the viscera, smooth, and cardiac muscle. So with their neurotransmitters, with the somatic, it's always acetylcholine. With the autonomic, they use acetylcholine, epinephrine, or norepinephrine. Now, figure 7.27 gives a good diagram of the breakdown, so to say. You have a good key on the bottom. You've got your preganglionic axons, your postganglionic axons, myelination, your preganglionic and the parasympathetic, you can see right here, traveling to a ganglion right here where we will release acetylcholine, then sending another message. And ultimately what its target or effector is over here. Okay, so with the somatic nervous system, as you can see, one nerve going from the central nervous system to the effector. With the autonomic nervous system, we have at least 2. Okay, so sometimes we will release, we will target a hormone to be released, with the adrenal medulla releasing epinephrine into the blood, so with the fight or flight mechanism, things like that. Now, with the sympathetic division, it's going to originate from T1 through L2, so that's thoracic 1 through L2. The ganglia are at the sympathetic trunk near the spinal cord. Norepinephrine and epinephrine are neurotransmitters to the effector organs. Okay. Now, figure 7.28 is it's a good time to talk about how and why we have these divisions. Now, what we see here is that for most of these, they are paired. Okay, so we have the eye parasympathetic coming directly from the brain stem, the eye in the sympathetic division coming from down here at T1. Okay, so the lungs coming from, again, brain stem. Over here, lungs coming from T1 again. Okay, so liver and gallbladder coming from, let's see, this is T7 right here. And these parasympathetic coming from, again, the brainstem. Now, this explains why if someone has a traumatic neck injury and they are a quadriplegic, that we can still have functioning here. Okay, but what's important to note is the actions of this. Okay, of these. Okay, so I'm going to jump to table 7.3 quickly and then go back. Now, as you read through table 7.3, you will notice that most of these are paired opposites. Okay, so you see right here with the lungs, for example, the parasympathetic effect of the lungs is to constrict the bronchioles. For the sympathetic effects, it dilates the bronchioles. Okay, now for heart rate, for example, okay, parasympathetic, it decreases rate, it'll slow and steady heart rate. Okay, with the sympathetic, it increases rate and force of heartbeat. Okay, so we have these paired opposite reactions, and that's for most. Now, sometimes with parasympathetic, we have no effect. Okay, so like for the adrenal medulla, sweat glands, but more times than not, we have these paired opposites. Now, let's go back to the parasympathetic division quickly. So the terminal ganglia are at the effector organs, and they always use acetylcholine as the neurotransmitter. Okay, so the sympathetic we often call the fight or flight mechanism. So it's this response to an unusual stimulus, and takes over to increase activity. So it's the E division, so to say, under times of physical duress with like exercise, embarrassment, an emergency, excitement, whatever the case is. Okay, and the parasympathetic is more like housekeeping. It just kind of keeps on trucking, does what it's supposed to do. Okay, maintains your daily necessary bodily functions for things like digestion, defecation, the removal of solid waste, and diuresis, the removal of liquid metabolic waste. Okay, so if you have any questions, please make sure to put it in the comments below or send an email to mr.tucker.schs@gmail.com.